Hello, everyone. My name is Daniel Lacorte. I'm Product Application Scientist for Ames Goldsmith Corporation. Today we'll be talking about the advances in metallic particle development and manufacturing and their impact on the paste in the final application. Just a brief overview. I'll give you a company overview, as well as where we fit in the supply chain, various printed electronics and where our materials fit in, what type of materials are used in these various applications typically, silver powder and silver flake, brief overview of various morphological changes and how they're manufactured, as well as some conductivity mechanisms, silver sintering versus interparticle contact on that non-fired application, silver sintering driven by organic composition, decomposition in this case, and some alternate cost-effective uses for some materials in printed electronics. So Ames Goldsmith is a 400 person company. We're headquartered out of Glens Falls in the US. We have three main business units: the print electronics, which is mainly our silver materials made out of New Jersey and New York. We have our precious metal and refining precious metal materials, as well as some silver salt manufacturing. So where we fit in the supply chain. So precious metals in this case, we'll focus on silver, mined out of the ground, which is then processed by the banks, which we then take and we use to make our silver nitrate. That is then the lifeblood of our plant. We use that to make our silver powders and silver flakes, which are then sold to your Nagases, your Heraeuses, your Henkels, for uses in printed inks, in conductive adhesives, for these military user electronics, PV, all sorts of applications that we all know very well. So some printed electronics applications where we fit in. PV, specifically PERC, we're typically sending micron-sized silver particles and flakes, usually on the larger side, higher temp. Then on the lower temp side, we have your heterojunction and perovskite. And these typically we will sell our submicron silver particles and flakes, less than 1 micron. On the conductive adhesive side, you have your die attach and your chip wire bonding. So this can be on your fired or your sintered materials. So this can be micron or submicron sized flakes, nano silvers as well as submicron silvers. Then you have your conductive inks here, so some non-fired applications. So these would be your flexible hybrid electronics, micron-sized and submicron-sized silver flakes and silver powders. Then you have your RFID printed antenna, automotive sensors. These type of materials will vary depending on the printing method or the formulation that the customer is using at hand. Overall, we manufacture the materials to best fit the application and meet the customer needs. Overview of silver particle manufacturing. Like I said before, we make our silver nitrate. So we go from our silver ions via chemical precipitation process to silver metal. In this case, there's an initial nucleation step where 20 to 30 atoms of less than a nanometer coalesce, and then they are either slowly grown to form these primary particle or crystallites that range between 15 to 40 nanometers. SEM on the top is a more crystalline material, so that's going to have a larger crystallite size on the range of 30 to 40 nanometers. And then on the bottom, we have a more polycrystalline material, which will be on that finer side, that 15 to 20 nanometers. Ultimately, we can control these via the precipitation process, size, particle size, morphology, particle size distribution. We can manufacture this on our processing side to meet the customer demands. This is another example of modifying the crystallite size. On the left, we have a more polycrystalline, smaller crystallite size material, and on the right, this is a larger polycrystalline material, so this is going to be on that range of 30 nanometers or so. And this can control the shrinkage in the final application of the material, either once it's fired, so on and so forth. These are around 1.5 microns in diameter. So same diameter and varying crystallite size due to our processing changes. Ultimately, we have the tools to manipulate most silver processes to meet these market demands. One of my more favorite materials that we have here are chemical precipitated plate